Hi guys, welcome back to the channel. If you're new to this channel, my name is Anmok Abdul-Wahab, and in this video, we're going to talk about how to use matrix method in solving systems of linear equations. Now, if you are new to this channel, make sure that you subscribe and then you like the video to help visibility of this channel. Okay, so let's just get right into it. Now, in this problem, we are looking at the same system of linear equations that we solved in the previous videos in this particular playlist, numerical methods. The link is down below. Make sure that you go into this playlist and watch all the other videos, right? So have a context of why we are solving the same problem with different methods. Now we're going to use the matrix method to solve this. So basically we have the same system, AX equal to B, where your A is the coefficient matrix. And you have your X, X1, X2, X3 equal to B, and your B1, B2, B3 is what this. So this is what you have and you want to solve. So we said in the first video in this particular series, we said that we can solve X by basically inverting A. So we take A to the other side, which means inverse of A multiplied by B. That means if A has an inverse, this should work out. Now, what we're going to do in the bulk of this video is to find A inverse. And there are several ways to do this. Now, we're going to use one of the methods that are available to us to solve this problem. Now, how do we solve A inverse? So basically, this is A, and we're trying to invert this matrix. All right. So how do we approach this? Right. Basically, the inverse of A is given by this formula, 1 over determinant of A multiplied by the adjunct of A. Now, what is the adjunct of A? We're going to see through this procedure what the adjunct is. Is basically you have a matrix with what we call C31, C32, and C33. Right, so we're gonna find all of these entries. Yeah, and this matrix is called, and each of these entries is called a cofactor, right? A cofactor for this entry, for this entry, or for this entry. And we're going to explain how to find these cofactors to determine the adjunct of A. Okay. Now let's look. So basically, the adjunct of A would be this cofactors transpose, right? We need to find the transpose of this at the very end. So this is what the formula is. Now let's look at the procedure on how to get this using this particular example. Now, C11, so how we're going to determine C11 is basically this. So you're going to multiply -1 multiplied by I plus J. So this is your I and this is your J, right? And then what we're going to do is we're going to take this the determinant of this component. So when you close out the first column and the first row, what do you end up with? You have 2 minus 1 minus 4, 2. So that will be your C11. So basically C11 is -1 raised to power 1 plus 1, right? Determinant of this. So what does that give us? That is just 1, right, times determinant of this. So which is quite easy to do. So determinant of this is what? 4 minus -4 times -4 times -1, that is +4. So this will give us 0. So that means the first cofactor is 0. Now we'll do this for the rest of the entries. Okay, so this one again, this would be -1 raised to power 3, 1 plus 2, right? This is the first one, this is the second one. So I plus J, 1 plus 2, that will be 3, -1 raised to power 3. Now, which matrix do we have? Basically, in this case, you're going to close in the second column and the first row. So let me just show you. So once we do this, what do we have? What do we have left? We have we have 2, I think 2, 2, then, oh, sorry. So what am I looking at? So we have 3 minus 1, 1, 2. Okay, so that's what we have. 3 minus 1, 1, 2. Now let's find this. So this will give us minus 1. Minus 1 raised to power 3 is minus 1, right? Now let's find the determinant of this. 3 times 2 is 6 minus 1 times minus 1 is minus 1. So let's have this. So this gives us what? 6 plus 1, which is what? 7 times minus 1, which is minus 7. So that means C12 is going to be minus 7. Okay. So we're going to do this for all the entries. So I'll be fast in the rest of the calculations so that you can understand, at least you understand what we're trying to do. Now this one will be minus 1 raised to power 4. So let's find this matrix, determinant of this matrix, which is close this the third column and the first row. What does that give us? That gives us 3, 2, 1, minus 4. So what does that give us? 3, 2, 1, minus 4. And that gives us what? 1 times 3 times minus 4, that's minus 12, minus 2, that's minus 14. Now C14, so let's find C14. Oh, sorry, C21 is the next one. There's no C14. So C21, that will be 2 minus 1 raised to power 3, again, 2 plus 1, that's 3. Determinant of what? Let's find it. So we close the second row. So we close the second row and the first column, right? So what does that give us? If you close this first column and second row, we have minus 1 here. Sorry, I think this is covering things up. So let me just write this. Let's just write this matrix: 2 minus 3, 2, 3, 2, minus 1, then 1, minus 4. Okay. So what happens now? We are closing this column and this row. So we have minus 3, 2, minus 4, 2. So minus 3, 2, minus 4, 2. Now what does this give us? This gives us minus 1. Then let's take the determinant of this. That's minus 6, which is, we are doing this diagonal multiply minus this diagonal. So minus 3 times 2, that's minus 6. Then minus 4 times 2, that's minus 8. So that will be minus 1 times what? Minus 6 plus 8, that's plus 2. Right? So we have minus 2. Okay. C22, that will be, obviously, that will be minus 1 raised to power 4. Then determinant. So let's find C22. That will be 2, 2, 1, 2. So 2, 2, 1, 2. And what does that give us? That will be 4 minus 2, which is just 2. Then C23. Let's look at that. C23. So we are closing this and this. So that's 2 minus 3, 1 minus 4. So 2 minus 3, 1 minus 4. And this is minus 1 raised to power 5. So what does this give us? This gives us minus 1. 2 times minus 4, that's minus 8, minus 3. So that's minus 1. Minus 8 plus 3, that's minus 5. So this gives us 5. Okay. So we are moving gradually. So let's see what we have so far. So we're going to find the adjunct of A, and we have, so far, we have 0, minus 7, minus 14. I have minus 2, we have 2, and what? 5. Okay. Right, so we have minus 2, 2, and 5. Now, what about the third one? So let's compute the rest on this side. Okay, C31, right? C31 will basically minus 1 raised to power 4. Okay. Minus 1 raised to the power 4. Then determinant of, so we close the first column and the third row. So that will give us minus 3, 2, 2, minus 1. And this will give us 1 times minus 3 times minus 1, that is 3 minus 4, 2 times 2. So that gives us minus 1. Now C32 is minus 1 raised to the power 5. Now let's find the matrix again. Close the third row and the second column. So the third row and the second column. So what is left is 2, 2, 3 minus 1. 2, 2, 3 minus 1. So that's minus 1. 2 times minus 1, that's minus 2, minus 6. So this is minus 8 times minus 1, that is 8. Then C33, this is the last one, minus 1 raised to the power 6. Then let's find the determinant. So the third column, the third row, that will give us 2 minus 3, 3, 2. So this will be 1 times 2 times 2, that is 4, minus 3 times minus 3, that's minus 9. So this gives us 4 plus 9, which is what, 13. So now we can complete the third row of this matrix, which is what? Minus 1, 8, 13. Now, we need to find the transpose of this. Don't forget, we need to find the transpose of this to get the adjunct of A. So the transpose would be what? The transpose is when you make the columns the rows. So the columns become the rows. So the first column becomes the first row. The second column becomes the second row. And the third column becomes the third row. Right? So this gives us what we are looking for. Now, what is next? So what's next is we need to find the determinant of A as well, right? So let's do it down here. So let's find the determinant of A, which we haven't done. Okay, so so we're looking for the determinant of A. So basically, you know how to find the determinant of 2. So this is A. So this is A. So let's write it one more time. This is A. Now the determinant of A is basically when we do this. So it's similar to how we found the covariance, not the covariance, the cofactors. Now, how do we do this? So we can basically choose any row or any column to find the determinant of A. So we just choose the first row, right? So it's 2, take the first number, the first value here, 2, then multiply by the determinant of, if I close the row and column that 2 belongs to, that will give us 2 minus 1 minus 14. Then minus the second entry. What's the second entry? Minus 3. Then determinant of, so determinant of what? Close the row and column that minus 3 belong to. What will be left will be 3 minus 1, 1, 2. Then finally, plus 2, determinant of 3, 2, 1, minus 2, right? I close the third row, the first row, and then the third column, right? What is left is 3, 2, 1, minus 4. Okay, so now let's calculate this. So this is 2 times 2 is 4 minus plus 4. So we have this. So this will be 0. Then minus times minus plus 3. It was this determinant. 3 times 2 is 6 minus 1. That's plus 1, right? Then plus 2. 3 times, that's minus 12, minus 2, that's minus 14. So basically we have 0 plus 7 times 3, which is 21, then plus 2 times minus 14. So basically 21 minus 48, minus 28, right? Which will give us minus 7. So this will be the determinant, okay? So now what do we have to do finally to get what we are looking for, A inverse? Remember we said it's 1 over determinant of A times the adjunct of A. So we found both, we found the determinant and found the adjunct. Now, remember that the initial problem is to solve X equal to A inverse times B. So this means to solve this problem, all we need to do is do 1 over determinant multiplied by the adjunct. What's the adjunct? 0 minus 2 minus 1 minus 7, 2, 8 minus 14, 5, 13. Then we now multiply that with B, right? Which is what? 9, 4, 6. So we just need to figure this thing out. So we multiply these two together first. So let's see, what do we obtain when we multiply that in those two? We still have minus 1 over 7 here. So what happens? So we'll multiply the first row with this column. So 0 times 7 is 0 minus plus. So that's 0 times 9 is, this is what we're doing, plus minus 2 times 4 plus minus 1 times 6. The next row will be minus 7 times 9 plus 2 times 4 plus 8 times 6. So basically the rows multiplying the columns, right? And finally, we'll have minus 14 times 9 plus 5 times 4. So let me enlarge this. So this is minus 14 times 9 plus 5 times 4 plus 13 times 6. So this is what we need to figure out. So this is minus 1 over 7. So this will give us minus 8 minus 6, that will be minus 14. So what about the second one? Minus 7 times 9 is minus 63 plus 4 times 2 is 8 plus 8 times 6 is 48. So if you do this, you should have, I believe, minus 7. Then, what do you have? Finally, what do you have? You have minus 14 times 9 plus 20 plus 13 times 6. So we need to do this calculation as well. And I think if you do that correctly, you should get minus 28. So this should give us minus 7. So you'll get minus 28. Right. So let's just go through the last one so that you can see it correctly. You can see that this is correct. So minus 14 times 9. So just basically do that. This is 36. This is 126. So minus 126 plus 20 plus 13 times 6 is 78. So what do you have? You have 126 minus 126 plus 98. And if you do this calculation, you're definitely going to get minus 28. So finishing up, let's just quickly finish off this problem. So what do you have when you multiply by minus 1 over 7? This just gives you 2, this gives you 1, and this gives you 4, which is the same solution set. So this is for x1, x2. This is the same solution set that we have on the previous methods that we used. So this is how to use the matrix method as well to solve this problem. Now, the only difficulty here in this problem is how we obtain the inverse of A. And what we have done is use this formula. Inverse of A is what? 1 over determinant of A multiplied by the adjunct of A. And to find the adjunct of A, you just need to find the cofactors, the cofactor matrix, and then find the transpose of that. So which is what we do. And in order to find the cofactors, you need to use this method I've just explained, outlined down below. Now, once you've done this, it's easy to find the inverse of A. All the next thing you have to do is just to multiply this inverse of A, multiply the inverse of A with B in order to find your X, and then you just follow through the multiplication, and then you get the final answer, right? Okay. Now, make sure that if you are not subscribed to this channel, make sure that you subscribe and then like this video so that this can give visibility to the channel. And then I'll see you guys in the future videos. I mean, if you guys want, I could actually make another video explaining how to find the inverse of A using row reduced echelon metrics, right? So if you want, please comment down below if you'd like to see that video, and then I'll make it for you. So enjoy the rest of your day and see you guys in the next video.